Good evening, everyone. Asad Allah masa'akum bikulli khair. Hello, my name is Maurice Pomerantz. I'm the Senior Director of the NYU Abu Dhabi Institute. I want to welcome you tonight to our first talk of our 15th anniversary season. Now, some of you may have seen that our new motto for this 15th anniversary season is Explore, Share, and Grow. And we have a packed schedule of amazing talks for this new year. And I encourage you to explore us on all of your social media channels. But I can't think of a more opportune way to begin this season than with this event, which is about exploration. Aristotle states in his Poetics that a great poet, and by that I think he means a great human, but let's just keep a great poet, shows the greatest capacity to find similarities in dissimilar things. For Aristotle, this is something that cannot be taught, and it is a sign of what he terms innate cleverness. Now, our speaker tonight, the cosmologist and jazz musician, Brown University professor of physics, Dr. Stephon Alexander, appears as one such person with these kinds of innate gifts. His academic work draws together cosmology, particle physics, and quantum gravity, exploring the relationships between subatomic particles and the vast spaces of the universe. Along the way, he and his colleagues have authored groundbreaking research that continues to extend such theories as Einstein's theory of general relativity, which we've perhaps all heard of. Tonight, though, Dr. Alexander will follow in some of the steps of that giant and others. We'll hear and these giants are folks like Pythagoras, Kepler, Einstein, and yes, John Coltrane, in thinking about how music and cosmology might have something to do with one another. Tonight's conversation will be the best kind of discussion, one that brings together two seemingly dissimilar things. And it is my double pleasure tonight to invite as Dr. Alexander's interlocutor, fellow explorer of uncharted realms, and other improvisational artist, our own multi-talented provost, Dr. Arlie Petters. Now, prior to joining us here in Abu Dhabi in 2020, Dr. Arlie Petters was Benjamin Powell Distinguished Professor of Mathematics at Duke University, a former Dean of Academic Affairs for Trinity College of Arts and Sciences, and Associate Vice Provost at Duke. Petters' principal research interests include mathematical physics, scientific methods in business administration. He focuses on mathematical finance and entrepreneurship, and you can see where this is going, innovation in STEM fields in developing nations, and a whole wealth of other talents that we know him for because he's here. So without further ado, I welcome you both to the stage and look forward to your conversation. Thank you.
Okay. Thank you, Maurice. I tell you, I extend a huge, huge thank you and welcome to such a rich and diverse audience. And in the spirit of our distinguished and honored guests, to really play jazz in this interview. You notice I have no paper, and we're just going to free flow and feed on each other. And we will also be honored with certain pieces that we will just simultaneously pick. And Dr. Alexander is going to play certain pieces as we engage in a conversation. So, but let us begin. You and I are from the Caribbean, and you're from a special part of the Caribbean, Trinidad. Tell us about...
I thought you were going to say Belize.
Well, you're a special guest. So, but tell me about those early days, the childhood in Trinidad, inspiration. Were you playing any instruments then?
It's interesting. Thanks. First of all, it's a real honor to be out here. I mean, wow, I'm blown away by Abu Dhabi and the Emirates. I was recently out. And this is a part of the answer to your question because the part of Trinidad I grew up in, so Trinidad and Tobago is a twin island republic. It is considered to be genetically the most diverse place on earth, according to a geneticist colleague of mine. So genetically, in terms of different people from different parts of the world. I know Belize is in a close second, because that's where Provost is also originally from. And so because of that multiculturalism, Trinidad was that place where, if I give the village that I grew up in, which is the southernmost coast of Trinidad, called Bastia. I believe it was in Columbus's last voyage, he mistook Trinidad to be a continent, even though it was an island. And when he got over to Trinidad, he saw South America, 7 miles away. Trinidad was named after Trinidad. He saw these 3 mountains, and he said, I'm going to name this one after the Almighty, of the Holy Trinity. So it's a very beautiful place. So, growing up in that type of nature, just as a kid, you're just in awe with the beauty, and it was very close to the ocean. Mm-hmm. And so I used to sit on top of a hill a lot. Mm-hmm. There used to be this hill, just sitting there doing nothing, staring at the rhythm of the ocean. Yes. And listening to just the rhythm of the waves. And I think that definitely it's a very musical culture. But because it's multicultural, you can't help but grow up with a lot of curiosity. Mm-hmm. So I think that combination of the curiosity, and just the sort of the musicality of the culture was a big thing. And when my parents immigrated to New York City, we immigrated to the Bronx, New York, in the 80s, early 80s. I actually didn't want to leave. I was like, why are y'all taking me away from this beautiful place? My friends are here, right? So that's the first impression.
That's interesting. So, growing up in such a beautiful, vibrant, energetic environment, you have the waves, right? The sea that's soothing and at times energetic, particularly if you're going to have a little storm come through.
Oh yeah, we have
or
storms.
A thunder shower. And then you sit on the beach, yes, Stephon, and you feel that breeze, which is also a fluid in motion. And so I'm getting that you have naturally been immersed in all these vibrations, right? And the steel pan. And I'm curious, at the early days of experiencing music and rhythm and vibration, were you exposed to jazz at that point? Or was it when you went to the US?
That's right. The jazz, and the jazz definitely happened in the U.S. But let's go back to the steel pan. The steel pan was an instrument that was, of course.
You all know what steel pan is, I assume. The beautiful.
The steel drums, right? It makes a bing, bing, bing. That sound, boom, 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 right? So and the thing, it was invented. It was the only, just an interesting fact, the steel pan or steel drum is the only instrument that was invented in the 20th century that was not based on any other instrument. So it was, and how it came about, it was interesting. So Trinidad is 40% from East India, mm-hmm. right? So people from India left India to come to Trinidad, usually as indentured servants or merchants. And it's also mixed with an African population, and of course everything else, yes. Chinese, some European, Lebanese as well, Syrian, okay? Mm-hmm. And so that's interesting because the steel drum is an amalgamation, it's a combination of the West African drum and the tassa, the drum, the Indian drum. Yes. So the way you beat the steel pan, the same way you have those drums from India that you put around your neck, and that during the Indian weddings, they roll it. So it has the same type of technique, but it's a combination. Yeah. And it's because of that mix, that instrument came to
well, I tell you, I think it's a perfect time for him to get on the sax and interpret that experience you had in childhood.
Whoa. He's going to make me improvise.
We're totally improvised. Why don't you give us your response to that through the sax?
Okay. Well, if y'all don't mind, do you mind? Okay. Let's see. Let's try something. I'm gonna have to improvise a steel pan. Okay.
Yes.
Okay. Let's see.
Oh, thank you. And so growing from those childhood days, you moved to New York. Tell us about when the physics and the mathematics and the exposure, when did that begin?
You know, we moved from one place in the world that, brought, all these different types of people from different walks of life, different cultures, Trinidad and Tobago, to the Bronx in New York, which is a home of immigrants,
Yes.
So people from all over the Caribbean. And in fact, I never felt more Caribbean away from the Caribbean. Because then, we had neighbors from Puerto Rico, from across the street from Pakistan. We had these Italian that owned a deli, the Amatos. Joe Amato was an interesting guy. He was a mob guy, unfortunately. He's a nice guy, though. He was great to the kids. The kids loved Joe Amato until the FBI came looking for him. Polish, Irish.
Yeah.
So it was that kind of neighborhood. And the jazz actually came in a very interesting way. So I used to listen to a lot of rap music because at the time rap music was coming on the scene in the Bronx.
Who are some of the rappers you were listening to?
Well, I mean, Rakim, okay? Okay, the great Rakim.
Yes.
Now, he was definitely a force of one. Run DMC.
Ron DMC. I love Ron DMC.
LL Cool J, when he was walking with he had a little leopard. Well, a jaguar, that means what's jaguar.
MC Hammer?
Okay, I used to listen to MC Hammer.
That Genie Pants?
Yeah,
How many of us remember that?
MC Hammer, right? Love me some MC Hammer, of course. Even Vanilla Ice.
Oh, yes.
Ice, baby.
Yes.
Right? So, that was, but one time I was listening to, there was this mailman, this Puerto Rican guy, used to come deliver mail, right? And I think I was homesick, quote unquote sick. And he walked by our house and he heard me listening to some music. I mean, that ain't music. He goes, tomorrow I'm gonna bring a CD for you. Back then we had CDs for all the young people in the audience. I'm gonna bring a CD for you. So the next day he actually bought a CD, and it was a CD of a sax player named Gato Barbieri. He's an Argentinian sax player. And the album was called Caliente.
Oh, yeah,
and that was my first taste, not only of jazz, but of Latin jazz. And that is the thing, because that music connected also to the Caribbean, because as you know,
yes,
Latin America is right there too. So again, the jazz, that was just a very natural part of growing up in the Bronx, right? Because it's really a music that combines different things as well. It's what we call a callaloo. Can you tell the audience what a callaloo is?
Well, how many of you know what it is? Oh my gosh. Well, this is surely something more in Trinidad. You enjoy eating this. So for example, if you take a plate of food And you look at that in the Caribbean, or you look at it in my own country, there's so much rich history already in that particular combination of inputs. And so I feel, as I take your journey, food, diversity of peoples, musical rhythms, you are not a normal math science genius kind of kid. Right? This man was immersed in all the different cultural and rich dimensions. You're immersed in the heritage. And then if we fast forward the story, Brown University, working on your PhD, how that journey happened.
That's a very interesting journey. In fact, one of my old classmates is actually in the audience. So he's here to check on me to make sure, my friend Muataz out there. So he's here to check and make sure I'm not pulling anybody's leg here. Well, I went to college. I did get into music when I was in high school. My friends created a rap group that I was a part of, even though I don't know how to rap to save my life, okay? I was making beats and that kind of stuff, and they were like, you need to go to college. We'll stay here and continue doing the rap music stuff. And I went off to college. And there in college, I didn't discover physics. I had a good physics teacher. I had a good high school physics teacher who was also a musician. Yeah. That's actually very important, because oftentimes when we, as young people, right, we tend to follow things not only based on the intrinsic interest, but maybe because of social pressures. Maybe we feel we fit more into this than that, right? Because society says so. So here I had this amazing teacher who was he looked like a little Albert Einstein himself, but he played the jazz saxophone. And he kind of made it okay. It was a normal thing to have this person who did physics and also played the saxophone. To me, it was like, well, that's a normal thing, because I don't know what's out there in the world. So I go to college, and I majored in physics and minored in music. Yes. And actually, I wasn't really some brilliant student or anything like that. I was a knucklehead, okay? It's important to say those things. So I really wasn't that focused. But anyway, I did know that the life of a scientist, meaning doing research, was a good con. You know what a con is? Like a good game. Because wait a minute, people pay you to hang out somewhere when nobody's watching. You're supposed to be doing research. I get paid. I don't have to, put in, you check in to get, what is it called? When you have to put a card when you start work.
The swipe.
Yeah. Check in 8 hours and somebody's watching you. So this idea of doing research, you think about things or you work on something. I was like, let me give that a try. And I had the opportunity because I had some really good mentors. And that's really, really important. So I go to Brown University. And again, Moots can tell me, that's his nickname, could tell you, I was probably the worst student in the first year. I was that dude, okay? Because I used to go to and hang out in the jazz clubs in Providence. That's where Brown University was at. I used to hang out with the jazz musicians, right? Because Providence was a very musical town.
Yes. So, as I listen to the story, and we're going to transition into the cosmology and the jazz now, you're someone that has gone along an unorthodox path. And I am sure you bring the heritage of the Caribbean, and there's a sort of spirit and soul that comes with this engagement throughout. You keep this connection with music. And I'm sure this unorthodox path you're taking, going for the PhD in physics, but not just any area of physics, particle physics, highly theoretical, very difficult, doing original research in that space. Perhaps let us now turn to all this rhythm. We know that the physical world is in vibration, and constant vibration. Everything is in relative motion. And we also know that it's very interesting when you look in physics And for those of us who are teaching this in J-term now, I'm sure you have touched on elements of it. But we learn a lot from Newtonian physics that you input the position and momentum of the particle, and then you can predict the trajectory. You know where this thing is going to go. Then comes quantum mechanics that messes that up, that you can't know these two things simultaneously. Therefore, the future path of the particle, you cannot know with certainty. Mm-hmm. So this thing, this uncertainty principle, shows up a lot, and in your book, and in the many other work that you do, mm-hmm. you're seeing these analogies mm-hmm. with physics. Tell us about that.
Yes, that's an important thing because my way, so yeah, I had to find myself a little bit when I was yes. doing my studies in graduate school, and what I realized happened in hindsight, looking back, I didn't know what's happening in real time, was that many of my musician friends were also seekers themselves. The music was just a tool for them to explore. They were exploring with sound. They were exploring, to find deeper meaning in their music and how the music affected people, how their own growth as musician and their own musicianship, their own practice. And so some of the principles, especially in terms of my mentors in music, in terms of the practice of music, I found that there were many similarities and overlap in terms of that, and especially in research. And the research that I engage in, and I'm sure we'll talk a little bit more about that, is theoretical. My lab is in my head for the most part, and my lab is with other people. We talk to each other. There's a lot of dialogue and debate going on, and there is a sense of improvisation there too, meaning that there's a structure which is maybe the theory that you're working on, right? The thing that the construct, or if it's the theory of relativity, there may be certain anomalies. I'll give you an example. The way the sun moves around the center of the galaxy, right? It moves at a given speed such that it's able to stay in a stable orbit, meaning that if it's moving too fast or too slow, the orbit that it takes around our galaxy will not be stable. There's an anomaly, and he's an expert in relativity. I read his textbook when I was a student. That there's an invisible form of matter out there that's keeping that orbit stable. We give it a name, dark matter, but we actually don't know what it is. But we know its affect, which is that we're happily sitting here on Earth. If that dark matter didn't exist, we would not be in a stable orbit. So there's a theory, but that theory has to confront an anomaly, which is something that the theory cannot explain, but it explains how this glass may fall down here very well. It explains gravity here, but it doesn't explain gravity out there. And so facing that anomaly, learning how to confront the unknown as a jazz improviser, and the practice that I learned from my teachers of how to, in real time, how to confront the unknown, right? There is improvisation is also a practice as well as it is an idea. Yes. And so it was those little ways that, so my music friends and teachers were really the ones that really inspired me to stay in science, because I realized that I had a way into my science through this practice as a musician. Yes,
that is interesting, and indeed, not knowing the next move.
Not knowing the next move.
Right? And so picking up on that, if we look into the origin of the universe, and we go back in time, we go to smaller and smaller time scales, right? Can be 10 to the minus 30 seconds after the Big Bang. And you go back to smaller and smaller time scales, and you inject this Heisenberg uncertainty principle, then the energies, if you know that time scale well, the energies are over this vast, crazy, it's mind-boggling.
Trillions and trillions of electron volts, yeah.
That's right.
Trillions and trillions.
And so when you're looking at the space that has that kind of energy, what happens to space and time, right? We hear of these quantum fluctuations, this crazy sea, right? And you could imagine the energies are so high that black holes may even form. You have these ruptures in space and time. So this is what we came from, yes.
According to the theory, this is what we came from.
When you first encountered this, with all that uncertainty, it feels to me like jazz at work, right? All these fluctuations. Could you help us interpret this in terms of some of the ideas in string theory and other theoretical fronts you have investigated?
Yes. So it's kind of interesting that, our theories, if you look at like sort of, when I say our theories, the laws that we now know in physics are usually governed by 4 forces, right? We have 4 forces. And it's really interesting when you look at the sort of anatomy, like the way a doctor studies the anatomy of a body, you can kind of look at the structure of these forces. They all have one thing in common. And I'm talking about this is known physics, is what we know, and then we can go into the thing where we don't know, is that they all boil down to wave-like motion, right? A fancy word for the mathematically minded, they all obey a second-order partial differential equations, all right? Which we were talking to the students in J-term this semester about the wave equation today, right? I see the students smiling there. Well, it turns out not only does electromagnetism, the electromagnetic force, and sound wave obey that, but also in some approximation of the nuclear interactions, they also obey similar types of wave-like vibrational type of motion. The problem is that they have to also obey the laws of quantum physics. So now you have to pepper this up with some uncertainty, with a lot of uncertainty, which means, as you pointed out, that you cannot know 2 things at the same time. For example, the position of something and how fast it's moving. You can only know, the more you know one, the less you know about the other, because in some very weird way, they're different aspects of the same thing. So when you're looking like at one part of it, you're disrupting the other part. Okay, so that's the basic essence of that. But it turns out that space and time itself, space and time, as Albert Einstein taught us, are also interlinked, right? So when we go back to the early universe at very, very, very early times, right, it turns out that time starts getting more and more certain because we're looking at more times, and therefore the notion of where you're at and what you're talking, what you mean by space, becomes completely uncertain. So the very construct of space and time breaks down. And we hit a wall now, because the human mind, when we start trying to conceive of this conceptually, then that breaks down, right? So we live in a, so how do you talk about no space and no time?
Yes.
How do you talk about these categories? And that's kind of where research in the field of quantum gravity comes in. And it turns out, I work on that a little bit. Well, and one interesting thing about that is that we have different candidate theories of quantum gravity, right? So there's one called string theory, where in that sense, we replace the notion of matter by microscopic fluctuating, vibrating strings of energy, and that everything is unified in the string. Different types of matter, the different qualities of matter, including space and time, are just different vibrational patterns of the string. There's another approach which says that, another approach of quantum gravity, which actually thinks of space and time as atoms, atomic entities. But either way, these different approaches are fraught with difficulties. I mean, right now, I would say that we're stuck.
Yes.
So we need new ideas. We need new perspectives, and some new jazz.
I think this is perfect time for going into the quantum vacuum, and you give us a piece that that speaks to the uncertainty, right? The breaking down of the structure of space and time.
For that to happen, my saxophone will have to come apart.
Well, let's give it a try.
Okay.
Yes.
You guys are not going to judge me if I, all right? If I suck. All right. I'll try something. I need an idea here. I need an idea. Somebody give me an idea.
Someone, please. Dark matter.
Okay, I like that. I like dark matter. Good. The what?
Okay.
Oh, okay. You just gave, okay, dark matter equinox. Very good. All right. So John Coltrane had a song called Equinox. Okay. And dark matter.
I felt all those quantum fluctuations. And so we're now going to move from the origin in those early stages in the formation of the universe. And perhaps walk us through maybe beyond recombination. So the universe, as you know, was dark. But after a certain point, it lit up. And light radiation is able to move around in it as the accelerated expansion of the universe goes forward. Structure begins to appear. And if we keep going forward in time into our present epoch, formation of our solar system, formation of Trinidad and Tobago, so this is the middle part of the story. Mm-hmm. Tell us a bit about this in terms of when you're looking at the formation of structure of the universe, vibrations, large-scale structure, moving out that quantum realm a bit.
Yes. Right, so the standard picture, and we have very good confidence, extremely good confidence. In the 70s, well, it's a little bit of history. When Albert Einstein came up with his theory of general relativity, which is basically matter and energy will warp and bend the fabric of space. I mean, this fabric is kind of, it's invisible, but it's still a fabric. We know that because the sun, for example, warps the fabric of space such that when space is warped, the Earth surfs the contour of that warping. So the circular motion of the Earth, or the elliptical motion, is really not any force, but the affect of the warping of space. And motion is really just planets moving around the contours of that warped space. So the other thing it predicted back in the 1950s, 1920s, was a solution called the black hole solution. And that was recently found right in the center of our own galaxies. And we've found thousands of black holes now, right? Another prediction was ripples of space-time called gravitational waves. Mm-hmm. And gravitational lensing, your specialty. So the idea that, well, I'll have you explain that because you can do much better than me. But anyway, the point is that we know that this is the correct description of gravity, which is space gets warped. Another way space can warp is that space could stretch, right? And that's the expansion of the universe. So that was another prediction by Lemaitre, who was actually a priest. He fell in love with relativity, and he found this solution of that, he called it the primeval atom, or the cosmic egg. The idea that the universe started off as one point and just expanded out under the action of some mysterious explosion. He actually uses it as conviction in his belief in God, actually, that God created this expanding universe. And we call that now, in modern terms, the Big Bang. So we don't understand the Big Bang. We have no way, it's still a mystery. But right after the Big Bang, there are predictions. Because since space-time expands, but space could ripple, the affect of the expansion creates this rippling effect. And it's actually that rippling effect, at some point as the universe expanded in this very, very hot, dense state, and cooled as it expanded, the light energy that was released and the radiation created an environment very similar to the surface of the sun. And that surface actually carries particular types of waves. Those waves are called pressure waves. Air is a pressure wave, so actually that medium carries sound. So actually the very first instance of structure in the universe started off as sound waves. Now the energy in the sound waves, okay, remember waves carry energy. And gravity loves energy. Whenever gravity sees energy, it likes to create attraction. Just like if you jump up, the gravitational force will attract you back to the earth. So the sound energy in the early universe, that's all there was at that time. There was no, right? Collapsed and coalesced to form the first stars. All right? So there are different types of stars that were formed. And everything I'm saying here have been observationally confirmed. All right? So this picture in the 1970s, your professor, Jim Peebles at Princeton, so when you did your PhD at Princeton, he predicted this in the 70s, and this was found in the early 90s by the COBE satellite and the WMAP satellite, David Spergel, and the Planck satellite, and he got the Nobel Prize recently for this prediction that the sound waves in the early universe were the things that ignited the first structure, the first stars, which then eventually created the planets and all that stuff. So it all started off as sound waves, and I find it to be completely, what's the word? Validating as a musician.
Yes. Well, I think that I would like to get a little philosophical for a moment.
Uh-oh.
You look at our audience and you think about this topic and what draws you in. We find ourselves on this planet. We didn't ask to be born. We're born. And we become conscious of the world. And for those who grew up in the Caribbean, like ourselves, very little light pollution. You look up at the sky, and you're seeing the result of this formation of structure through thousands of stars that you can see with the eye. But then all of this stuff is happening. We don't understand why. The laws of physics, one of the things you learn is that you don't put a person in there, that this thing is going to be true in the sense of the scientific method, no matter who is the observer. And you have this rich diversity of reality. And then you're listening to Run DMC in the clubs, and you're feeling this rhythm. And it can even be trance-like at times in the way music moves us. It could feel mysterious. And then you have all of this other stuff that we're trying to understand in our reality. And so I recall as a child thinking about these things. Learning the mathematics, I felt a philosophical grip that also had an aesthetic balance to it, an aesthetic draw that I also got from music, or just listening to you play what I would call the quantum vacuum, right? You just improvise that. So this connection.
Thanks for the title of my next album, Quantum Vacuum.
This connection between the human experience and rhythm and music, and you're looking into the world right? That you sense there's some resonance, that what is happening on Earth in some ways, that there are similarities in the structures theoretically in what you see out in the cosmos. And if I pick one example, gravitational lensing has to do with the interplay of gravity and light. And if you have you're drinking your coffee, put some cream in it, and it's hot enough, you're going to see that famous curve that's shaped like this. You have the cusp point. These structures that you're seeing right in your coffee cup, the light in the universe acted upon by this Einstein theory and the gravity, in other words, creates light caustics in the universe. And it does it at any wavelength. It's similar to the stuff you see in the coffee cup. And so if
So that was a lab experiment. You used to drink coffee.
That's right. And so this earthly thing that is ordinary, that can even move you in its beauty, it shows up in the structure of the equations that are governing these things we see. Yeah. Tell us about that feedback as you look at these connections and the analogy, how they inspire your jazz practice, right? Or how they may, in the reverse, inspire your physics.
Well, I'm going to have to embarrass another person in the audience, and one of NYU's own Robert Rowe, the great Robert, the legend pioneer.
Robert is right over there in the corner hiding.
My hand. Okay.
Welcome, Robert.
So,
he's teaching a J term with Stephon.
Yeah, and we're teaching a class called Jazz, Hip Hop in the Cosmos, Hip Hop, Jazz in the Cosmos, which is exactly this point. And it's kind of amazing that NYU Abu Dhabi is the first place to have a course like that. So you guys should be very proud to make that happen. Thank you, Carol. Carol Brandt over there. It's funny you're saying this, because you're saying this, I was laughing inside of me. I was like, man, this is nuts. Because when I was back in in 2008, first of all, people consider me, I'm a serious academic physicist, okay? I do have to pay my bills and write papers and do all that stuff, with all the reindeers, play the reindeer games, okay? However, there is this part of me that always, even after I became a professor and got tenure and all that stuff, I was still dabbling in the stuff. And the way I used to do this was I had friends in New York that would have events. And there was this place called the Cornelia Street Cafe in New York that would have these events where they brought artists and musicians and scientists and thinkers. It was started by a person named Mandelbrot and Roald Hoffman, a Nobel laureate who was a poet in chemistry. And he invited me to come talk about the Big Bang in music. Obviously, it's the East Village in New York, so anybody would listen to me, right? I mean, it was a place of a bunch of weirdos, like myself. So I have a great audience, and who else was there? This music composer person who was talking about trying to teach how a computer character learn how to improvise, and it was him, Robert Rowe. So here we are, talking about different aspects of music, and in this case, music and computation and computers and artificial intelligence, and in my case, physics, the universe, and music. Again, these are very out there, ill-formed ideas that were not to be taken seriously in the academy necessarily. However, there was, an intuition, going back to the point that you raised, that we sometimes see certain themes repeat themselves in different situations, right? Little did I know that one of the fathers of modern science, Pythagoras, the Pythagoreans, and even other cultures going beyond just the Western cultures, for example, when we look at certain Eastern music and Arabic music, for example, like the music had a cosmic vibration to it. I was unaware of all this. I was ignorant. So this conversation that Robert was really the interlocutor, the person that really got me to really start taking this connection very seriously. And then I ended up writing a book a book, The Jazz of Physics. And it was the writing of that book that took me further down the rabbit hole. And I started discovering that there were other people out there who had long before me been thinking about this connection.
Yes, well, I tell you, this artistic impulse that I believe in many ways, and my dear biologists in the audience, this is speculation on my part, but all my instincts tell me that there's something to it, that music, the arts, are somewhere embedded deeply in our DNA. And I feel that it begins in the early days, even if we look at the literary arts and that which is storytelling. You look at some of the paintings, it's trying to make sense of this reality we find ourselves in. And it also comes with a soothing, I would say, aesthetic and rhythm and vibration that is expressed through drumming that you saw in many cultures, others orally, in all these different forms, that at the end of the day, the artists, the scientists, all the people of inquiry, we're dealing with the same thing in different forms.
In fact, you just inspired me to actually prove something, his point to you. I'm actually going to play a sequence of notes here. The only thing was going to be an experiment. And what we're going to do is, I'm going to ask you all we have to completely deplete all of our senses except the sense of hearing for this thing to work. So on the count of three, I'm going to ask you all to close your eyes and just listen. Okay? 1, 2, 3. I'm not warming up first. Do you remember does that sound familiar to you? That's a Love Supreme. All right? And I just played up and down different registers, but actually the scale that is derived from is the pentatonic scale, which is the universal scale. Every single culture, this is a scale that is most used. And it turns out that that scale is actually based on the energetics of the physical energetics of the vibration of a wave. So in other words, if I create any disturbance, any type of vibrational pattern that's natural, it's going to play something called, it's going to generate a harmonic series. It's going to generate other wave patterns that are energetically, meaning minimizes the energetics. Right? It optimizes the energetics of this natural vibration. So it's a vibration that's natural. It's embedded in everything that's vibrating. And those vibrations, it comes out naturally from the pentatonic scale. You can generate it from this scale. It is natural. And that's why it exists. So if you solve the equations of string theory, for example, it's going to spit that out. If you solve the equation of electromagnetism, it spits that harmonic sequence. I mean, there's some, obviously there's some we don't want to take this too far. Clearly, there are different types of wave patterns, as we'll learn in class today with FM synthesis and things like that, right? But I find that to be, again, this is kind of makes the point that you're making, right? That here's an example of natural vibrations generating a scale that is universal amongst human beings across the earth. Cultures that never spoke to each other. In Ireland, that is the scale, as it is the scale in Morocco, as is the scale when I listened to the Carnatic music the other day. It's still there, even though they're doing microtones, right? They do their way, right? But I find it to be amazing.
Well, I'll tell you one of the things that, as one would listen to your journey, it's the holistic story that you are not putting a separation between the scientific activity. You're bringing in all these other human elements in the arts. And this kind of interwoven experience is one of the areas that I think is extremely important. And I feel this nexus of the arts, of technology, the sciences, and on, NYU Abu Dhabi tries to create an ecosystem that will approach that space without judgment, allowing everybody, including you, to explore and experience this connectivity between us and the mysteries of the cosmos, right? And so if we go back to the universe, this thing is expanding, getting bigger. Dark matter is the bulk of it. Then there's this thing called dark energy,
oh, God, don't get me started on
that we're trying to understand. And I say that as we're going towards the latter part of the conversation, when you look at the future of the universe and the best models that we have for that, tell us a bit about this.
We're lost. Yeah, so we have theories that, again, work, so what science to me is a well-defined barrier between things that we know very well and things that we don't know at all, right? That boundary, right, is kind of very well defined in science. I teach a class at Brown. It's a graduate level class called Quantum Field Theory. It's a graduate level class. At the end of class, we do a calculation where we can determine theoretically a quantity up to 13 decimal points of accuracy. With it's a calculation, okay? And this is measured at Fermilab and the Large Hadron Collider, up to that. But then beyond that, it's anybody's guess. Beyond that 13 decimal points, there are anomalies. But that 13 decimal points, we know it very well. So that's science to me. And the theories that we are dealing with is that 15 decimal point. Right? So what is this? It's not 13 decimal points now, it's 120 decimal points, okay? So we have measured the effect of some form of energy that is nothing like the energy that we're used to, and because we don't know what it is, of course, we give it a name. We give a name to things we don't know, so we call it dark energy. But we really don't know what this thing is. It's a place filler, okay, for something we don't understand. It's very important to keep an open mind, but it doesn't stop us from theorizing. And there are hundreds of models of dark energy. I myself have about 5 or 6 of them. Okay, and I'm actually getting them all published, by the way. Okay. All right, but the point there is that we have these. So I'll give you an example of what one of these theories are. So I have a colleague. He's a brilliant person. I won't name him, but he's a really smart person. And his idea is that there are kind of space-time bubbles that are created. Like you're taking a bubble bath or something. So these bubbles are being created in space-time. And as these bubbles are nucleated, meaning that they're created, right? That basically the dark energy is the action of creating these bubbles in space and time. I mean, it's kind of a weird idea that these bubbles in space-time that's popping in and out of existence as we speak right now. Where are these bubbles? They're quantum bubbles of space-time. Right? So that's one crazy idea of dark energy. My own energy, I have a theory of dark energy that actually says that dark energy well, it's not really my idea. This was done by a person at another place, that there are wormholes, like little tiny portals in space-time. And what the dark energy is the act of these wormholes that exist. And so the idea, and that's actually one of the things I do like about science, right, is that there's a place to play. But going back to your point, you said something that really, I think, I cannot stress how important it is, at least for me, in academia, especially this is a place where discoveries are made and these questions are being asked, for us to find ways of bridging the silos. And I think that if we want to really pass something on to the next generation, I think that's the practice and the attitude that we should have, right? That these things that we call a field today was a mixture of some other thing, two fields, like, you're not a real biophysicist. Well, there was a time when there wasn't a field called biophysics. There was a physicist and a biologist, and they spoke to each other, and a field was created. Now I'm not a biophysicist. So this idea of, because that's how knowledge actually is furthered and created. It's really where these interfaces happen, right? But it doesn't mean that we don't also, we don't know our stuff and we're not grounded and we don't know how to solve the equations. It's not an either or, that we don't respect the traditions. But to forge forward, I think it's super important. I mean, so I was really smiling inside, especially hearing it from a provost, okay?
Let's pick up on that point as we go into the tail end of the conversation. So we have this whole sociology that's connected with science, with the arts, and these silos, almost like you said, in a lot of older traditional ecosystems, you almost need a visa if you're in the arts and you want to go and talk with the physicists. And each develops its own sense of importance and can cause others to not feel a sense of belonging, to not feel welcome to explore across the divides. And I feel that this is something surely that AI is breaking down.
Interesting.
Right, as it allows more access. But for the moment, we spoke of the journey, your experience with music, with the physics, but the human coming back to earth, that human engagement to maximize the probability that young people, folks at different stages of their career, could play in the sandbox, rather than you have situations where certain sectors feel that this is my sandbox, I will dominate it and decide who's to come in. We know this sense of superiority, and it plays in these identities that keep people out. Tell us how you have experienced this in your journey.
Well, I mean, it's very clear that in a field like physics, where, and again, I was, definitely, I'd love to say, I definitely experienced that. I mean, some of the spaces that I occupied were places that were, they considered themselves to be very prestigious. Maybe we're number one type of attitude. So what's this guy doing here? It was more like, back in those days, I had very long dreadlocks, so I kind of had a look about me. I carried a certain type of personality. So I could see, honestly, even if I were me, not me, seeing me walk in a room in some ivory tower somewhere, and I'm thinking I was number one at Princeton, and I'm sitting here and I worked really, really, really hard, and what's this Rasta guy coming in here with his thing after a night of clubbing? And what? How could we let this guy in? This kind of thing. We definitely had some of that, right? At the same time, I was fortunate. I mean, I had this. When I was one of the brightest physicists in my generation, I won't mention the name of the place. Somewhere in the west coast of California, okay? But he came from Iran. His name was Shaheen. He was brilliant, extremely brilliant. But he and I became buddies because he loved that. In his view, I was some kind of genius because clearly to be looking this way and acting this way, this guy had to be really smart, right? So different people read me in different ways. But the bulk of people read me more of like, this guy's an interloper, he's an imposter. Clearly he's a fake, and we're gonna find him out and we're gonna out him. So there's definitely that kind of stuff going on. But that to me was it was a great gift because I did make it and I did succeed, right? And that was, 30 years ago, something like that. So what that's done, it's like made me it's creative. I have really good antennas so that now that I'm the professor, now that I run the group, right? I have all kinds of weirdos now, like, I really try to by example, let students know, especially, that you bring your best when you bring yourself. And it's perfectly, and I've been so fortunate to meet some of the most brilliant people that they don't look brilliant, they don't act brilliant, right? And so, like, to me, it's a really big loss. In fact, it's a great recruitment tool. You know what? Yeah, you actually don't pay attention to that person. You come here, come talk to me, right? So I think it's, so from my experience, I definitely experienced it, and I still experience it. And I know I'm not alone. I know that there, Shirley Jackson, one of the great nuclear physicists, won a National Medal of Science in the United States. Just the other day she was traveling and she had an experience, right? So again, this is, but for me, I sort of feel like I'm in a I also find it interesting, and I've learned how to, while it sucks sometimes to have that feeling, right? I also know I'm not alone, and I see great opportunity with that.
Yes,
right?
yes.
Yeah.
So I will say that...
Try to put a positive spin on it.
Exactly. Yeah. So with the diversity comes all these sort of human engagements and tensions and lost opportunities. In fact, when I was a graduate student, I remember Shirley Jackson interviewing me. It's interesting you mentioned her name.
Was it when she was at
for Bell Labs? For Bell Labs
okay.
Fellowship. And so you may know Bell Labs is where superconducting was discovered. They have the only physicist who won the physics Nobel Prize twice. And indeed, this whole issue, whether it's gender-related, race, ethnicity, religion, and all of that, what I love about NYUAD and what I love about the UAE is the importance of tolerance.
Big time.
The importance of coexistence. That, to me, stimulates peoples from all over the world. You just sit here in the audience who can come and catalyze creativity. And to me, that is how a great nation moves forward. And so I say, watch it, the UAE. It's taking its place on the world stage in this regard.
I went to the mosque, and I almost fell to tears. Yes. Seriously, I was blown away. And especially there was a part when you enter into the mosque, and it had a sign, like some words about tolerance.
Yes, yes.
And that really spoke to me. Yeah.
So could you give us a piece about the hopefulness for humanity and for your visit here at the UAE and NYU Abu Dhabi? And then we'll open for questions.
Okay.
Right?
I'll try my best.
thank you for this most amazing human journey, Stephon.
Thank you.
And we will, so Maurice, you could help us with this. We will open for questions, comments. Yeah.
We have microphones over here.